Hi everyone. In this video, we are going to learn about stack data structure. So the agenda of today's video is what is stack, and we will see some real life examples where stack is being used, and we will talk about operations which we can perform on stack, and we will see some application where stack is being used. Before jumping into the definition of what is stack, let's try to understand using some game. Here we are going to explain about stack using Rocket Stack game. So in this game, we are given one stand. So this is the stand or pole ring which you can consider. So here one end is completely closed. So this is the end which is closed, and another end is here which is open. And here you have given some set of rings or discs in which you can add using this open end. Either you can add or remove using this open end. Let's see how exactly it happens. So now we got disk 1. So we have to insert this using this open end only, right? So let's insert disk 1, and currently this is the topmost element. Now we got disk 2. Again, we can able to insert only using this endpoint because other endpoint is completely closed and we can't even add anything. So disk 2 also added. Now we got disk 3. Again, how we will insert? We will add to this using again this open end. And once we add disk 3, now this 3 is going to be the top element. Now we got disk 4. Again, disk 4 also we can add it using this open end. So let's insert it. So if you notice it, we are able to add the disk one after the other using this open end only. Here we are allowed to add only one disk at a time. Now if we want to remove 3, we have to first remove disk 4 because which is topmost element in the stack, right? So this is the final stack which we have achieved after performing adding 4 disks, and we have removed 1 disk, right? So here if we notice it, this is the disk which we have added first. So this is the first disk which we have added. But if you notice it, when we can remove this disk, we can able to remove what are the disks on top of 1, right? These are the different disks, whichever on top of 1. So this means the disk which added at first, which we are calling first in, is going to be out of it at the end. So which is last out, right? So the disk which we have added first is going to be removed last. So that's why this is called first in last out. And again, if you notice it, we had another disk which was 4, and this is the last disk which we have inserted. So last in, the last disk is going to be removed first. So this is also known as last in first out. So stack is also a data structure. So data structure is nothing but which is used to store and manipulate the data. But this has some specific quality that whatever we added at the end is going to be removed first, or whatever we added at the first is going to be removed at last. So these are the two things which we are achieving if we are using stack data structure. So stack is a linear data structure which is used to store and manipulate data, and it which follows how the data is being manipulated. It is following either first in last out manner or last in first out manner. So last in first out is also known as LIFO. So this is called last in first out, or first in last out, first in last out. So this is going to follow either last in first out or first in last out order. Now we'll see some real life examples where we do see this stack data structure day to day life. So first example, playing cards. For example, two people are playing cards. Then we will be having some cards which will be placed exactly this way only, right? So this is called stack of cards because the one which is on top is going to be picked by either one of them in a single chance, right? So this is also like a stack data structure exactly which is following last in first out or first in last out manner. If you see second example, books rack. So for example, we are having books rack like this. So we are going to place, this is something like this, books rack. We are going to place books like this. And let's assume that books length is more than the rack length. So this is the only this much length only possible. Let's assume that this is the book length, right? Which is crossing the rack length. Then how we will place it? So in the same book rack, we will keep one book on the another. So this is also like a stack data structure, right? So the topmost book is easy to access. Then the book which is at the bottom means this is the first one which got which we have placed it usually removed at the end. So that's why frequently used books we try to keep it on the top. This is one more example which we can think of. Third example is whenever we go to restaurant or buffet system, we do see stack of plates. So plates keep one on the another. So something like this. So something like this. Then we always try to pick the first one only, right? Because it is easy to access it. So it is easy to pick that plate which is on the top. So this is also, if you notice, is exactly stack of plates, and this is stack of books, and this is stack of cards. All these places we are going to access top element which is added. So these are the couple of examples which we see in day-to-day life. So by seeing these examples and what are the operations, how we have performed, let's try to understand stack data structure operations. So in this game, what are the operations we have performed? First one is adding the disk. So in stack, we mention it as push. We are pushing the disk into this rod, right? So this pole. So first operation is push. Add an element to the top of the stack. So currently this is the top element, right? Suppose we are going to add one more disk, then we have to add only on top of this. So current top is this one, on top of it, right? So this is, now it means that this is going to be the top element. And second one, what we have done after adding 4, again we have removed it. So this is called pop operation. So second one is pop. Remove element from the stack. And again this remove operation, always the top element gets removed. For example, I have removed, then this is going to be my top element. Again I have removed 3, means I have popped out, then 2 is going to be my top element. Third operation is peak element, getting the top element in the stack, because this is the only element which we have access to. This returns peak element in the peak or top element in the stack. Fourth operation is stack is empty or not. So is empty operation. That means that we are going to check whether do we have any disk into this, do we have any element present in the stack or not. Let's see some applications where stack data structure is used. First one is Tower of Hanoi game. So the Tower of Hanoi game also exactly look like this, but Instead of having one pole, we will be having multiple poles, and we need to move this disk from one pole to another. So first one is Tower of Hanoi. In detail, these things we can discuss later. For now, I'm just mentioning what are the different applications Stack is being used. Second one is browser history for forward and back requests. For example, in a browser, first I visited some website. Let's assume that link 1. So inside link 1 page, I found some other link which I want to visit. Then once I click on it, from link 1, it will open link 2 in the same browser window. Let's assume here it will open in the same window or the same tab. And again from link 2, I can visit some page if I have hyperlink, and then it will move to the another page which is link 3. So from page 1 we went to page 2, and from page 2 we went to page 3. For example, I want to move back to my previous page. Then we can do using back button, right? So in a browser, if you notice it, you will have the two buttons. First one is back button, second one is forward button, and you will be having something like refresh also. So using this back button, from link 3 we can move to link 2. So here, suppose whatever the page you are visiting, suppose you will keep it in a stack. So this is link 1 and this is link 2, and you are inserting link 3. And I want to move to the previous page, means what I can do? I can simply remove the top element, which is pop operation, right? So after removing it, I'll just put into another stack. And again, suppose if I use this forward button, I can again visit this page 3, which is on the top of this stack again. So here we are using two stacks. So this is one of the application where stack is being used. Similar way, we have undo redo operation. So in this undo redo operation in any text editor. Let's see how exactly this also happens. So first I entered letter A. Then I entered letter B. Then I entered letter C. Then I entered letter D. Now I want to undo. That means that I want to remove this D letter. So then D letter gets removed. Let's assume that D got removed from here. Then suppose if we click on redo again, this D letter will add it back here. After this, I did undo. What will be currently in the text editor? ABC. Then again, I did undo. Then in the text editor, we will be having only A and B. So now, for example, I'll do now redo operation. So then C has to add it to here. And again, I do redo operation. Then C has to add to be here. So in here, what we can do, whenever we are entering the letter in the text editor, at the same time, I'll put into the stack. So A entered, B entered, C entered, D entered. Then this is stack 1. I did undo operation. Then D has to get removed. But this also we have to store, because we can do redo operation again, right? So we are having one more stack. When D gets removed, it will be added to the stack 2. And when C gets removed, it will be added to the top of the stack 2. Now again, if I perform redo operation, the top element picked from S2 and will be added back to the stack 1. So this is how stack data structure is used in undo and redo operation in text editor. So fourth use case is code syntax matching. If suppose this is the opening tag, then it has to be ended with end tag, or even in XML also. For every opening tag, there should be some end tag. Otherwise, we are going to get some issues, right? So this is also So here also we will use stack data structure whether the syntax is properly matching or not. Fifth one is especially recursive call stack. So call stack in programs, especially where we have the recursion code. This will use internally stack data structure and then the function call is being stored in the stack. So in this video, we have covered all the points, whatever we have mentioned here. In coming lectures, we will see how we can implement this stack data structure. So the stack data structure is mainly implemented using array or dynamic arrays. Even we can mention it as the array list also or linked list. So one after the other, we will see how we can implement stack data structure using these basic data structures. So I hope this video is very helpful to you. Thank you for watching. Stay tuned. Happy learning.